Hello Joe, welcome to a quick follow-up video. So this video is designed to be a direct follow-up to my anchor point tutorial video. However, this is going to be a technique that we can use to optimize any sort of large data management using two-dimensional arrays. So if you've seen my other video on how to manage complex data using two-dimensional arrays, we are going to show how to create a more optimized solution and make it more memory performant. So in the last few minutes of my previous video, I mentioned that one of the problems with setting up our two-dimensional arrays this way, in the way that we've done in several of our videos, is that this generates a very large array of empty data, and we end up allocating a ton of memory that we don't end up using, which is relatively wasteful, especially if we do this for a ton of objects or just a ton of different data throughout the game. Then this wastefulness kind of starts to grow. So how can we turn this, this implementation of two-dimensional arrays into a more memory performance solution? Well, the quick, simple solution to this is to use DS maps. The way DS maps works is it takes a key and a value pair and it inserts it somewhere into memory, and we don't really care where it exists in memory. So unlike an array where it gets created incrementally and linearly and all the data is stored one after the other, DS maps don't work that way. So what we need to do is we need to find some way to turn our two-dimensional array into a DS map. Well, how do we do that? Well, let's get started. So the first thing we're going to want to do is we're going to want to create our DS map. So I'm going to say global.anchorData. Now normally, by just having this first line here, we are defining global.anchorData as a two-dimensional array, but we want to define it as a DS map. So we're going to say global.anchorData equals DS map create. And the first thing we want to do anytime we create any sort of data structure or volatile object is we want to destroy that whenever we are no longer using that. So in the game controller, I'm going to say DS map destroy global.anchorData. So now we have destroyed that map when we are done with the game. And so now what we need to do is we need to find some way to turn this two-dimensional array into a key value mapping. Well, we already have the value here, and that is just what we are inserting into the array. So we don't really need to worry about the value aspect of the key value pair. We just need to find some way to turn our integer-based indexing into a string-based indexing for the map. So how can we do that? Well, the very, very simple solution is, let's say we want to work with first this insert of data. So obj player and SBR player idle are our indices that we're using to store this array of anchor points. Well, instead of using these obj player and SBR player object index and sprite indices, what we can do is we can say var key equals string object get name obj player, and we're going to say plus underscore plus string sprite get name SBR player idle. Let's close off sprite get name. Let's close off string. So now what we've done is we've taken the object name of this obj player object index, and we've taken the sprite name of this SBR player sprite index. We've casted those to strings and we've joined them using an underscore. So what this will look like is is essentially the same thing as saying key equals obj player underscore SBR player idle. And that's essentially what our key is looking like. We are constructing this string dynamically using this object index and this sprite index. So now what I want to do is, instead of accessing this data using these two integer values, we are going to say, I'm going to first put a question mark to indicate that we are accessing a map, and we are going to pass in our key value. So now if I go ahead and delete this line, you can see that we have no errors, and this is a proper implementation of a DS map. So how do we then pull this data out? So if we wanted to, we could go through and we would copy and we would do the same thing for each of these lines. So we could say this, we copy this here, we can copy this here, copy this here, and then we just have to replace some things. So SBR player 1 run, SBR player jump, SBR player fall. Okay, and then we can just kind of copy this and one more time. All right, and so now we have a fully implemented DS map that holds all of the data that we were holding in our two-dimensional array. So how do we go about then accessing this data? Well, I'm going to go ahead and use the implementation and build off of what we did in the last video. But again, if depending on how you're using this in your project, your implementation of it might be a little bit different. So I'm going to go ahead and open up our obj turnip, which is the object that is pulling our anchor point data. And I'm going to go to step. And here you can see we are trying to pull that array of points using a two-dimensional array. Well, we would do this same sort of accessing of the data the same way that we inserted the data. So we would say var key equals string of owner dot object index. And we want to say object, because if we just do this is an object index and this is going to be some sort of integer value. So like, for example, I think the obj player index value is 20. So this would say 20, but we don't want to get the object index as a string. We want to get the name that belongs to that object index as a string. So we're going to say object get name. And then we're going to say plus underscore plus string sprite get name owner dot sprite index. All right, so now we have constructed the key, and all we have to do is we're going to remove this. We're going to say question mark to indicate that we are accessing from a DS map, and we are going to pass in key as our key. So now if we go ahead and run this project, we should get the exact same output. And you might be thinking, okay, well, that's not that exciting. What's the point of that? It just produces the same output that we had. Like I said at the beginning of this video, this is a way that you can optimize your two-dimensional array implementations, convert those into maps, so you get that memory performance, but you don't lose the formatting, the organization, and the structure benefits that we get by using two-dimensional arrays. So we get kind of the best of both worlds. This is a solution that I just recently discovered, so it's the reason why I haven't implemented it in previous videos and in previous projects, but I just wanted to share it with you guys because I think it's a relatively easy solution, a relatively easy thing to do. It's just really a good idea to try to find ways to optimize and improve the performance of your code whenever you can, whenever you see little vulnerabilities like this that might become problematic later on. It's just good habit and good practice to try to find better solutions all the time. Thanks so much, guys, and I will see you in the next video.